Before we get started, a couple things. First of all, recently I'm an extremely infrequent public speaker, okay? So if I kind of like, between the heat and the anxiety and stuff, have some kind of old man freak out, I hope it doesn't make the news, okay? So, and then the second thing I wanted to show you guys. So I got an email from my friend Dan, who unfortunately is not here this afternoon, who sent me this product listing. These are available from AliExpress and from Tindy, I guess for about $200. And this is an old 386 portable computer. And I looked at that, the mail he sent, and I said, man, I need one of those for my presentation. And I knew it would never get here on time, so I did bring an alternative old school technology, okay? So anyway, let's see where we're at. Okay, so how many of you learned Python as your very first programming language? Okay, and how many of you learned Python as your first and only programming language? A few people, or one person anyway, very cool. Okay, so my first programming language, which I learned in high school, was Fortran. But the only language on my home computer of that era was BASIC, okay? The Beginners All-purpose Symbolic Instruction Code. Now there's a good name for all of you programmers, Pythonistas. That's fantastic. There's no good name for BASIC programmers. But I'd like to suggest Basists, because that rocks. Okay, so anyway, I think names and languages can be important, especially for beginning programmers, which is really my focus. I'm very interested in duplicating the experience that so many people of my generation had with their first home computers, Commodore 64s or original IBM PCs, where you turn those computers on and literally 5 to 10 seconds later, you're in an environment where you're writing code. And that seems largely missing today. I know there's a lot of great tools like Scratch and Code Combat that are teaching kids to program, but I would really like to revisit the idea that a simple dialect that starts up immediately and runs very simple could be something interesting. And Python is so well regarded and such a nice looking language. I think there's, and maybe CPython is this. The truth is I don't know CPython very well, and maybe it has exactly the features that I'm going to talk about in this talk, so you can correct me later about that anyway. Okay, so when John Kemeny and Thomas Kurtz designed BASIC in 1964, their goal was to create a programming language that both English students as well as engineering students can use, okay? So luckily they had some inspiration. There were some existing languages. And I want to tell you, I actually had minimal experience with some of these in school. Yeah, I'm that old. There is no way an English or history student or anyone else is going to learn to program in those languages. Okay, so much for inspiration. But I think they did a good job. And their very first hurdle was the equal sign. So in a mathematical sense, mathematicians at the time thought of equal as meaning, the equal sign as meaning equality. In other words, one side of an equation evaluated to the other side, okay? And furthermore, the result was typically on the right, not on the left. So, 25 divided by 5 equals 5. There we go. Okay, so they had to kind of get over that hurdle. So the idea that x equals 10 seemed kind of wrongish. But let x equals 10 is very obvious, and I think it's the sort of thing that an English student as well as a math student or anybody could understand. What's going on? We're letting x equals 10. Okay, that's pretty cool and obvious, I think. Eventually, the let keyword kind of got disused. Most later dialects of BASIC simply ignored it, which then matches very well the current Python dialogue, or dialect. So x equals 10, you'd see that as a variable definition in Python. So anyway, I think the explicitness that let demonstrates is an excellent thing when it comes to describing what's going to happen, particularly for beginners. Okay, imagine it is 1964 and your job is to write a new programming language for that hardware. I have always been amazed at the programs that clever people can create with almost no compute and memory resources. There was a popular magazine back in the 80s called Dr. Jobs' Journal, And they would occasionally write these articles about very minimal size programs. What does this program do? And then the readership would get involved and they'd send a letter saying, oh, now I have a smaller program that does the same thing and stuff. So that certainly existed. And you think, well, who could write a language in that? Well, obviously some smart people could. But I really see the user interface as being the problem in this case. That's it. You know, you type in a line of code at the teletype terminal, you enter it, and the line goes off to the mainframe to become part of the program, and then you better not make any mistakes. And that's the whole thing. So the next feature that they came up with, or was certainly part of the programming vernacular in general, was the idea of line numbers, okay? So you can see what's going on here. If that's the system prompt up there, you know, we've entered some lines that, oh, crap, we misspelled Dr. Kurtz. So by simply re-entering the line number and replacing the line contents, that line was replaced, and then the further listing shows the new program. So that was a way to do very, very cumbersome, but yet effective editing on programs of that era, on those computers. So the next thing that I think they were thinking about was, how do we do control flow? What we just saw in those previous two slides was a way to do an ordered list of instructions or statements that would be executed in order. But we need to jump around. We need to do stuff. And this is well before reasonable functions or any kind of fancy stuff going on. So I have a feeling that goto is their next thing. And goto, if you've never seen it, you can tell what's going on in this line numbered basic here. On line 40, if I is less than 10, then we go back to line 20 and we complete that loop until we bail out. Now, so first of all, is there anyone here who needs this level of explanation, or am I just going too far down the obvious stupid stuff? Okay. Here's another more modern dialect of BASIC. And this one actually uses labels. So in this case, we're using a label, but essentially the logic's exactly the same. And the reason I like this is because when this compiles, when the computer gets a hold of this and turns it into machine code, when it executes on the CPU, it turns into a set of instructions that looks very, very similar to this in structure. We get down to the JLE start, and we jump on less than or equal back up to the start label. And whether this actually runs exactly like my loop over here, I don't know, because it's highly dependent on interrupts on the x86 machines and stuff to do the print, but you get the idea, and I think that's pretty obvious. So I like the fact that goto is really a one-to-one mapping of what the processor is going to do. So when you're learning, I really like the idea of combining the idea in a programming language along with what the machine is going to do for beginners. I'm not suggesting this is a high-level way to do effective coding. And you can see what the inspiration was. It was obviously assembly language code. So goto does have a downside, though, and most of you, I'm sure, if you know, might know what it is. And that is what was called spaghetti code. If you have a real program, of course, not only are you typically jumping back, but you might be jumping forward, you might be doing it in overlapping ways, and all of a sudden, what the heck's going on? So that was called spaghetti code. As a matter of fact, the preeminent computer scientist, Edsger Dijkstra, wrote an ACM paper in 1968 titled "Goto Statement Considered Harmful." So he wasn't interested in anybody programming with gotos. But I would argue that there is a situation where even in modern coding, now I know Python doesn't have it, but C and C++ and some other languages do, and that is bailing out from nested loops. I'm sure you've all been in this situation, and you know, you've got some nested loops going on and I want to get out. And one way or another, that requires the establishment of some conditional elements that are going to be tested in the outside loop to escape. Now, in recent decades, I've kind of put that test right up in the for loop in C. But the nice thing about the goto is that you get out of the loop in one jump, it's minimal instructions, and the logic is very simple. And I totally appreciate people who think that's a really stupid idea and hate goto. I have no good argument, but that's my feeling about it. So. Okay, so another thing that my recent experience has shown, I have, in my old man career, I have literally written over 1 million lines of C, C++, and JavaScript code. And all of those are very C-style programs that use curly braces for block structuring. They use semicolons as statement terminators. They use parens for surrounding stuff that not only doesn't need it, but stuff on the line. So that adds a lot of visual noise to the program. Here I've highlighted those potentially optional characters in my code, and I think the code would look clearer without that. So here's an example here's a comparison of 3 languages. This is a non-recursive function for calculating the nth Fibonacci number. So in this case, we've got C++ on the right, Python in the middle, and then my dialect of BASIC, which I've been writing recently, which is part of my current project, on the right. And it's really similar to old school BASIC. It just has a couple niceties and a couple things where it's not adding extra stuff. And I think Python here is the clear winner for clarity. I mean, it's awesome, but it benefits greatly from the fact that the indents are required. Okay, and I think that can potentially be a good thing. I've written so much C and C++, I just don't see code that same way. But I think that the basic version is certainly a little bit cleaner on the page than the C, C++ version. But the Python here is the clear winner. But I would like to complain about one thing in this Python example, and that is the range function. So in the C, C++, or even the basic version, what I like about the for statement there is that it's got 3 parts. It's got an initialization, it's got a condition, and it's got an action. And it's all right there on the page. I've written it, I can see each part, and as a beginning coder, I can see those 3 parts and understand exactly what's going on. The problem with range is, first of all, it's a far more capable function to put in there. It can enumerate a lot of different stuff, as most modern languages have some, what am I talking about here? Some iterator or collection-based loops, and those are very, very powerful. But they do require some non-local information. So range is very powerful, but you have to know what it does. And again, I don't know, I'm sure it's a fantastic feature, it is, but for a beginner to see what's going on that line, to me, I like that notion. Okay, so anyway, as this was the previous slide from 2 ago, my version of BASIC, I'm pretty happy with the syntax. I think it's pretty clear on the page. I'm not super crazy about the ends, but without requiring indentation, of course, it's the block closure. So what I've done, compared to most dialects of even BASIC, is that I've eliminated the terminating kind of new block start that's at the right end of those lines, but the end is still required. And I do have a question, and maybe somebody wants to tell me about this later. Syntactically, from a parsing standpoint, those colons in Python don't seem required to me. I mean, the next block starts on a required indent anyway, so why are those colons there? I just don't know the answer to that. I tried to do a little Googling to try to figure it out, and no one had a good answer other than this is what they do. So I'd love to hear about somebody who thinks that's a good thing. So, sorry. Oh, one last thing about parsing. Unfortunately, in my version of BASIC, and most versions of BASIC, a statement end is implied by the fact that there's a new line at the end of a line. So new lines essentially become statement ends. I think it's really easy to code that way, and certainly Drs. K suggested that if it was too long to fit on a single line, then you needed to break up the logic in some way. So I like that, and I also kind of like the idea of line continuation characters where absolutely necessary to break up longer lines. But the idea that a statement fits on a single line, once again, for beginners, I think is pretty good. Okay, so by the way, Microsoft got started when Bill Gates and Paul Allen wrote the basic interpreter for the Altair microcomputer. And then that was spread to many of the home computers of the early 80s. Here's the Altair kit on the side. If you've ever seen the movie War Games, David Lightman has an IMSAI computer, which is very similar to the Altair. So that's a place to see a computer from that era in action. So the other thing I want to say is, I'm embarrassed. I don't have a single slide that has cats on it, okay? But I do happen to know that this studio shoot of Paul Allen and Bill Gates, this is the second shot they did in the studio. And in the first one, they both had a long-haired Persian white kitty that they were petting in the earlier photograph. So that picture, unfortunately, has become unavailable. And obviously is a really bad joke. So I think the last thing I want to really talk about is compilation. What does it mean to compile something? Everybody knows. We turn a program into machine code that then executes right on the CPU as opposed to being interpreted. And there are some things that make a program easy to compile. And those are static types, structured flow control. Most functional features are easy to compile. What's hard to compile, dynamic types are harder to compile, not necessarily impossible. And then impossible to compile are things like eval, and it's pretty obvious. When you're going to assemble a string that has, you've got to have a way in the runtime to execute whatever that turns into. And then finally, meta classes. I've never used meta classes. I don't really get them, but I'm pretty sure you can't compile them. So the reason I think that, I guess I kind of talk through now is static typing versus dynamic typing. You can kind of get it. I'm sure you guys kind of understand what the problems would be. Static typing, you're basically saying, here's a type. The compiler can pre-allocate the place that that type is stored and how it's represented. When it's a dynamic, a variable that can change dynamically, you might set it to one type initially, and then later you replace it with a different type. So the storage changes, other things change and stuff. But like I said, it's not impossible to compile that to machine code. It's just more difficult. So, and then, as I said earlier, when code has to be evaluated at runtime, it makes it impossible to compile. And the reason I like compilation is because, as in the early go-to example, when you can take a snippet of code and say, what does this look like on the machine? What's the assembly language version of this machine, of this code look like? You can really, I think, begin to understand the computer engineering aspects of the software engineering problem. And I think that's an educational thing that might be missing from current education, particularly for software engineers. I know there's still computer engineering programs and stuff, but my focus is really not only kind of on older school hardware, but it's also on embedded systems. If you can create a operating system for something as simple and primitive as Arduino that is effective and turns into code, I think the learning opportunities around that could be quite awesome. So, what did I preach is the question. I like the let keyword. I like goto. Maybe not for common use, but certainly for a learning experience. I love the idea of developing a mental model of how the CPU executes code snippets. And I think source code whitespace is really good. When things look very clear on the page, I think that's a good thing. I think it's easier to read the code, and I think beginners would have an easier time with it. And then seeing the code where it's used is also good. I like that. Sometimes you lose a lot of power doing that, and things get a little crazy, but it's a neat technique for beginners to learn with. And then finally, Bill Gates was a pretty smart kid. When I was getting older and in the industry, you think of Bill Gates and, oh, what did he do? Well, he wrote the basic, interpreter when he was really, I think, still in very early college, or even started on it when he was in high school. And that turned ultimately into Microsoft. So, we often think of modern visionaries as being, oh, they're so far. No, he was a pretty smart guy. So, how much time have I've probably gone way too fast, right? Yeah, it's about 20 minutes in. So let me say just one thing. My current project is called Revision PC, is this current company I've started. And our product is really something called Retros Basic. And I feel terrible about shameless self-promoting, so I want to tell you I feel pretty shameful about mentioning this. But if you go to that website, you kind of see where we're headed. I'm hoping that the software, as a Windows desktop, standalone, real simple programming environment, will be available sometime by the end of July. And we're also releasing a couple of very small embedded boards, one based on the Raspberry Pi RP2040, which is a terrific little ARM processor, another one based on a Chinese processor called the Milk 5 Duo, which is a dual-core Linux. And I don't know what the Arduino thing is. I just got these the other day, and I haven't had time to mess with them. But I think that both of those will make very compelling embedded system. You know, you've got an OS running on them. You connect with a dumb terminal or perhaps some program like an Arduino interface or, you know, the Retros Basic app that talks to them and do your thing. So anyway, I don't know. It's, I really enjoy the old school aspects of this stuff, and I really appreciate your time listening to me. So.